Welcome to the launch of the Cartographic Projection channel, a channel about education of mapping and the globe. My name's John, a cartographer from Victoria, Australia, and hopefully I can enlighten you on how some of these things are done. So straight off the bat for the first video, I thought I'd do something I've always wanted to do and finally got off my bum and did it. The Erastosthenes experiment, doing it here on the Equinox on September 23rd, 2021. So a quick bit of background, what is the equinox? Well, most people know that the Earth's tilt gives us our seasons, so we get summer in June in the Northern Hemisphere and summer in December in the Southern Hemisphere, but in March and September we have an equinox where we get equal amount of daylight for the day and night. And what this means is that, importantly, the sun's rays are coming in parallel above the equator, so we can use that for a form of measurement. So who was Eratosthenes? Well, he's a Greek mathematician who over 2,000 years ago worked out the size of the Earth pretty close to what we accept it as is today. And he did that by assuming that the sun's rays are parallel. He knew it pretty much on the solstice, that the Cyene, which was almost on the Tropic of Cancer, there was no shadow down a well, but he also knew on the same day that there was a shadow in a column in Alexandria. And by knowing the distance between the two, he could work out the angle and how much of that was for the circumference of the Earth. So what does that mean for us? Well, going back to the equinox, knowing that the sun's rays are directly over the equator, that can be our control point. And by measuring the angle of the sun as to where we're at, we can actually work out our latitude on the face of the Earth. So like I said, this year the equinox was on September 23rd, so I worked out when the local noon was here, which was 12:12 and 29 seconds. And while I was at it for working out our board, worked out the magnetic declination for the area I'm in. And that gave us all the settings we needed to try and set up the experiment. So what we have now is a video of me whinging about the weather outside. There's a hell of a lot of racket out in the background, that's why there's a voiceover. I've got an old bit of broom handle and a piece of flooring left over from a recent renovation. And we're just hoping for a break in the clouds, which did actually eventuate. So, chopping out a lot of my whinging about the weather, I've got my pole height for the shadow at 493 millimetres, and I've got my board marked out and set up for what I thought at the time was true north, even allowing for the magnetic declination. And so I was ready to roll, running on the weather. And here we are with the break in the weather finally, almost right on the right time. Got my laptop here to show the right time. I'm being super geeky about it and getting it right on 12:12 and 29 seconds. We're lined up with a good shadow, not quite on true north. Problem that I caused, I'll explain that later. But as we come up to the exact time, getting ready to mark it. There we go with my big gimpy hand in the way. As you can see, I've made some other marks along the way, just pointing out exactly which is the right reading, and just as another sort of point showing that all the markings produce a straight line. And so a few minutes later, just showing that the mark is right on 360 millimetres. And so we come to the results. So we have the height of the pole was 493, the length of the shadow was 360, working in millimetres, working in real units, as opposed to all those other weird old imperial units. That gives us, our angle there is arctan of length over height. Just an aside, my first teacher teaching that taught us as tan to the -1 because that's what was on the calculator at the time. I think that was year 8 or year 9, so that would have been 83 or 1984. Showing my age a bit there. Anyway, so I've actually got to stop and think every time someone says arctan or arctan, I think, oh, hang on, that's for me tan to the -1. Even though I've been taught that every year ever since, I still cannot shake that first time of what I was taught. So we get 360 over 493, which gives us 10 of that. 36 degrees. So 36 degrees, 8 minutes, 16.02 seconds. Yes, I'm being very anal on my calculations. And going by what some of the online stuff says where we are, 37 degrees, 22, 43, as opposed to our calculated one. That gives me an error of 1 degree, 9 minutes, 6.41 seconds. 1.28% of the 90 degrees, which for the very first go and for the very first time I've ever done it with a fuzzy shadow, I thought was pretty good, if I do say so myself. And now taking all that one step further, we'll go the same steps as Eratosthenes and try and work out the size of the Earth. Now I've got Google Earth's position here. It reckons we're at 3717. So get that as a decimal degree. And I do take an imaginary point directly north of me to the equator where the sun's rays are shining straight down of 4,144 kilometres. So doing the circumference calculations, we get the size going by Google Earth of 40,006 kilometres, and that's pretty close to the equatorial circumference of 40,075 as the accepted figure. So working it out on mine, I've got 36.13 degrees for the circumference, same distance because that's what I've got, and I get a calculated circumference of a slightly fatter Earth, 41,282 kilometres, which gives me an error, 1,200 kilometres, so a good long day's drive, 3.19%. And like I said, for a first go, never done it before, I reckon that's a fair sort of effort. Despite being so pleased with myself, there was one glaring error. I had everything set up and thought about it for weeks beforehand, but as I was setting up and having the levels nearby, a tradesman turned up and I forgot to level up the board. I had the stick vertical, but forgot to make the board completely level. You can see it's level on one side, but a bit out on the other, and that's why my true north line didn't line up with the solar noon shadow, which I initially blamed on my Apple iPhone, but nah, it was my fault because I forgot. So kicking myself over that, so I'll try and sort that out maybe by the solstice. If not then in 6 months' time in the March equinox. And so some assumptions. How many points do I have? I have 1. Admittedly, that's not even as much as Eratosthenes had. I have an arbitrary second point on the equator. I don't have a bloke to step it out for me like he did 2,500 years ago. And using that distance from Google Earth, I have assumed that it's a globe because that's how I perceive the world, considering that's what I do for a living. So obviously, if I'm ever at anywhere else on the solstice, I'll take measurements there and over the years, hopefully build up a set of points for a more accurate reading. And as I stated earlier, there was a reason why I replaced all the sound with a voiceover, and here's why. And for those of you wondering what the racket was in the background, this is next door. So if you've made it this far, I hope you enjoyed my first attempt at an Eratosthenes experiment to launch the Cartographic Projection channel. If you did like it, then please hit like. Feel free to subscribe if you wish. I would not complain in the least. And hopefully I'll be back soon with some more experiments on the shape of the Earth. And everyone, please take care. Bye for now.